so that we would get a chance to cross-pollinate from the optical society, from the optical community into the Open Compute Project Foundation, as we are launching a strategic initiative this year around optics. And DJ is here as well from our project leadership and steering committee leadership to be part of the discussion, partially for that reason. And I want to thank Vlad from Light Counting for really helping me pull this all together. Several of the panel members are people that Vlad knew and brought into the discussion. And I know Vlad and I went back and forth a number of times because we were thinking we might start off talking about co-packaged optics, and then we started to look at the agenda and we said, well, there's no reason for us to talk about that. Everyone else is, so we need to talk about something else. And so we tried to leapfrog forward and say, okay, what's beyond that, or what are we looking at going forward? And so just to give you a bit of facts about the Open Compute Project, it's 10 years old today, and we all know, I think, that it was launched by Facebook and a few handful of others, including Andy here, who was part of the founding membership. And today we're very pleased that we have near 300 members. And so we've gone from a gang of 5 or 6 to 300, which we're very happy about. And the other thing that we're also very pleased about is we have near 5,000 active participants on our mailing lists and in our projects. And while the staff of the foundation is rather small, we're about 10 people, we have 250 volunteer leaders that help us run all our projects. And I don't have the exact project count for you, but it's somewhere between 40 and 50 projects. It's not 50, but it's a little more than 40. And the other thing we're very pleased about is we look for diversity. And if you look at our membership list, by the way, which is on our website, so our membership directory is open, just like everything else about the Open Compute Project, you will find that we have members from all walks of life, from component providers to device providers to software system integrators, and we have adopters from the major market segments around cloud providers, around telecom, around enterprise. And I think that's the most I wanted to impress upon you. Yeah, one last thing I'm going to leave you with, and I'm going to turn it over to Vlad. So if you wanted to understand what is the Open Compute Project about, it's very simple. It's about the community that at the core has hyperscalers who need product in volume that is the latest and greatest product that we can get because of their scale. Working with other elements of the community that have joined them, what we refer to it as the hyperscaler ecosystem that supplies them, their supply chain. We refer to it all, the other constituency that's really important for us is the IT ecosystem, which is the supply chain that supplies everybody else. And those are the main constituencies that come together along with the end user groups to have discussions around innovations. Those innovations lead to specs or white papers or blueprints, and those blueprints are then used by the IT supply, the IT ecosystem and the hyperscaler ecosystem to build products at volume, and then everyone in the market benefits. And that's what we're about. So please think about that when you think about the OCP. And the last thing, as I turned over to Vlad, to let you know, if you wanted to tap hyperscaler innovation, you can join any one of our project calls. You can take a look at any one of our specs. You do not have to be a member. It's free. It doesn't cost you anything. You just need to get involved and take the time to find out what is available. Okay, with that, Vlad, I'm going to turn it over to you. I think you've got your own mic. So maybe you can introduce yourself and the panel can, and we can get on with the discussion.
Perfect, perfect. I'll start with Advertisement of OCP. I've heard about OCP Summit for many years, but last year was the first time I attended it live. And it was still during the pandemic in October, but it was a surprisingly interesting event. Not only you could see a lot of hardwares that Facebook and Google were showing at the exhibit floor, but you can meet people that I never met before. I mean, one of the sessions that I went on the first day, which was a kind of a future forum, the session was on AI hardware. And I walked into a room and I see a dozen of people, and it was kind of late afternoon, and I was thinking, well, maybe I should go take a nap. But I decided to hang around, and because it was so few people, we decided, well, let's introduce each other. So I discovered that there were 2 people from Google, 2 people from Facebook, 1 person from Amazon, 1 from Apple, 1 from Broadcom. I have never seen so many hyperscalers in such a tight audience, and of course, as you imagine, Amazon didn't say much, and Apple didn't say anything besides his name. But it was at least a starting point for a discussion. So I was pleasantly surprised, and I would love to help Cliff to get the optical community involved, because I think the more interactions we have with the end users of products, the better it is for everybody. So that's part of that forum, and I'll start with introducing the panel. I'm going to skip Andy because he doesn't need an introduction. He hates to hear about all his accomplishments. He heard it so many times. But I will let the panel introduce themselves, and I'll start with Chris on the other side. So Chris, if you don't mind just introducing yourself, even so people know you, and tell a few words about your company as well.
Sure. So my name is Chris Fisner. I'm currently head of marketing and sales at Abyssina Tech. I have a long career, 25 years in optical networking, first 10 years more on the system side, then 15 years in the module side with household names like Neophotonics. I finished our transceiver business. I built the Lumentum transceiver business originally. I spent 2 years at Jabil Photonics looking at the manufacturing aspects. But this one's different, but this panel is being different, so I think we're in the right place. We actually build gallium nitride-based, micro-LED-based interconnects for chip-to-chip communication. This addresses the bottleneck that I'm sure a lot of you have heard about by now in HPC, artificial intelligence, machine learning architectures. And what you get with these links is you get low energy, picojoule per bit or sub-picojoule per bit. You get high bandwidth density. Think beachfront, 1 terabit per millimeter and up. You get low latency because these are massive parallel links. And you get, you trade this off with reach. Obviously, LED-based links, those are not lasers, so you get short reach. Think up to about 10 meters. It's really dispersion limited, both modal and chromatic dispersion. And whenever you do something new, of course, you have to think about how are you going to scale this. Well, we're leveraging existing ecosystems. So we're leveraging the micro-display LED ecosystem that is rapidly evolving. I mean, gallium nitride-based LEDs, they've already revolutionized pretty much the lighting industry. And then on the fiber side, so we need multi-core fibers. But again, in the imaging and and lighting fibers, again, these ecosystems exist. You just need to adapt them. Stage of our company, we've proven out the technology. We're now in the prototype stage, and plan is to have first product in 2023.
All right, thank you, Chris. Mian, you next.
Yeah, so I'm Mian Zhang. I'm the CEO of Hyperlite Corporation. Myself, I've been working in the field in silicon photonics for, I think, since about 10 years ago. I got into the material and device physics side. So I was training in silicon photonics and love it, and also have problem with it at the same time. So I think I was very lucky to get into contact of a material called thin film lithium niobate in my postdoc career, and there was some pretty exciting breakthrough there. So it's one thing leads to another. Now I end up being in a startup called Hyperlite. We're commercializing thin film lithium niobate technology. I think the most exciting part of this technology is that it's probably one of the first photonic platform that uses existing material. Lithium niobate is a well-known material, but with the CMOS-like fabrication process. And what you end up having is a material that with significant performance benefit, but also not a lot of material risk because it's a proven material. And the best part is that it's also, there's an organic path of ramping it up because it's not we don't have to ask the users or vendors to dramatically change their supply chain. So that's really exciting that we have enough technical advantage to overcome the barrier of the initial ramp. And so that's, but this is still relatively new technology and there's several points that need to be proven. So that's what we're working on. But that's short.
Thank you. Thank you. Alan?
Sure. Alan Liu, CEO of Quintessence. I have a much shorter career span than Chris. So did my PhD in silicon photonics at UC Santa Barbara with John Bowers, and then I spent about 2 years in Washington, D.C. managing photonics programs for DARPA and ARPA-E, including Lighten, which is where I first met Vlad, and DARPA Pipes. And then decided to start Quintessence or co-founded with John. So what we're working on at Quintessence is developing a technology platform combining quantum dot lasers and amplifiers with DWDM silicon photonics. And so the goal is to develop a platform to support DWDM connectivity solutions up to 2 kilometers, initially targeting 1.6 terabits per fiber, a few picojoules per bit, and scalable to higher data rates via more wavelengths and or higher baud rates. So pleasure to be here.
All right, perfect. So NDL, since I skipped your introduction, I'll ask first question to you, is that we know that the industry is booming. The demand for bandwidth has never been higher. How do you think it's going to change over the next, say 2-3 years, maybe even 5 years if you can? And what the implications are to optical devices, optical connectivity?
So I thought you guys in charge of making forecasts here, but let me say first, it's really great to be back here in person. I've not seen many of you in literally 3 years. And I also will say that one of my saddest recent moments was 2 years ago, on the verge of the Open Compute Summit. We had to cancel it like the Friday before the meeting because large companies just said they couldn't travel anymore. So this was kind of hopefully we're beyond this. But going back to the optics here, I mean, clearly there's, I wouldn't say infinite, but very, very large demand drivers for optics, AI clusters, faster CPUs, etc. What's getting harder, and I think where OCP can play a role, is that the investments required into these next generations of optics are going up. We're hitting the limits of physics, electrically, thermally, material systems. There's new material systems, and the truth is, it only matters when it gets to volume and it gets the cost down. But ideally, we have some more open discussion, no pun intended, on what are the right directions for the industry to get there. And OFC here is a great place. It's once a year, right? People actually talk to each other. It's a great technical program. It's wonderful. But then it's like people go on radio silence and there's NDA agreements and I'm doing this and you're doing this. And then a year later, it's ECOC, I guess. But my feeling is there's not enough of an open discussion around where the optics need to go, right? And this starts even with modulation formats, right? Part of the industry believes 200 gig PAM4 is the right direction. There's some people who want to go all the way out to 400 gig QPSK in the same time frame. And maybe they're both right, but in the end, both of these things need significant investment to get there. And again, not just on the DSP side, which is going through the roof on tape-out costs, but also on the optical engines that can deliver that kind of performance. And it only matters if it works, if it's mature in volume. And there's a minimum 2-year lead time from now until then to get this all done. So we got to have the discussion on the specs today, not next year or the year after, right? It's too late. So I do believe that bringing that discussion into OCP has a real benefit. And in particular, focusing on the power element, which is not everybody's complaining about it. It really becomes a constraining factor at the rack level, at the data center level. Not that optics dominate the power, but existing data centers cannot accommodate the next upgrade because there's not enough cooling in that rack, right? So shall I talk about the thing we want to do here? Or?
Maybe a bit later then.
Yeah. Okay, we'll talk about that later.
Yeah, so
but we did have an announcement, or rather some idea of how to focus the industry on this power question, and again, we'll defer this for a little later.
Right, so just to remind everybody that the topic of discussion was beyond silicon photonics. And silicon photonics, actually it was exactly 10 years ago when Cisco acquired Lightwire. So that was a big bang moment in the history of silicon photonics in the industry, not in research. And as we expected, it gradually gained market share and according very close to our forecast. It's actually beating our forecast now. It's about 25% market if you look at transceiver sales at silicon photonics. So you can say it's a mainstream technology, it's good for this and that, et cetera. But it's not the reason to stop looking for new technologies that can bring more benefits. And I'll start discussion with a question from Young. And from your opinion, what are the limitations of silicon photonics? You kind of hinted that there are a few things you didn't like. So I'll let you elaborate on that a bit.
Yeah, so you know, I did my PhD with Michal Lipson back in Cornell. It was you know, in the early 2010s, and so the silicon photonics, you know, so I measured the chip with my own hand, right? So I had that chip there. It was difficult. It was just like, you know, there's a lot of things like two-photon absorption, there's biasing, there's a lot of things that you have to take care of. So you have that feeling. And then, you know, when we were touching with thin film lithium niobate, and it's a natively electro-optic material, you put light it, you put electric field, and you just have to have 100 gigahertz bandwidth. It's the material advantage is very, very big when you're opening to this, you know, other possibilities. But it's always a tough problem when you introduce new materials. It's probably one of the most difficult ones because if you look at the, you know, the options out there with new materials, there's probably, you know, you can easily name like, you know, 5 to 10 out there. And it's not a question, simple question of yes or no, are they going to be useful or not useful? It's more about timing as well, like when are they going to be useful? And that question is, I think the only person that knows that answer is the material, the people that worked on the material themselves. And that's what makes this direction particularly challenging. Is because even for me, I had the opportunity to work with silicon, I had the opportunity to work with lithium niobate, but other materials I don't have opportunity to work with. And one of the thing with the device, what we find, even with the lithium niobate, thin film lithium niobate, is that as you start to push it into commercial product, like, you know, when you do the demo, you feel like you have 90% of the job done because you have this awesome product that is, you know, saving a lot of power and running at high speed. It sounds like a 10%, but you realize the actual effort is in the 90%. And one little thing could catch you off guard. You know, miles later, you find out, oh wait, I have to burning every single device, and that's completely destroy my cost benefit. You know, examples like this. And then for investors, for industry leaders, if you're not a material scientist, it's hard even to ask the right question. So I think that's one of the biggest challenge, I think, for us is like, you know, is to I think we try our best to foresee it. That's one of the reasons I think I personally believe in the thin film lithium niobate, because we really think about this, the real, you know, how realistic it is to solve all those problems in time. But to, I guess, to convince people or to have open discussion about it, sometimes it's challenging because it's the material science, and some of it is just material physics, and you can't solve that with money.
So you mentioned there was a breakthrough in thin film lithium niobate technology. What was this breakthrough? When did it happen?
It was around, I think it was around 2016. We were etching this material. This material is hard to etch. I think people know it. But what the lab actually has been working on it for like 10 years. So here's the most difficult problem. Most difficult problem is not the etching itself. It's whether people believe that it can be etched. Once you know it can be etched, it's become much easier. But you don't know it. So when people have been etching it for many years, but the loss is around 5 dB per centimeter. Okay, so if you make a module on lithium niobate with 5 dB per centimeter, you have no advantage with silicon. So why do you waste all the effort to make that material? But through somehow, you know, I think a luck and understanding of the process, we're able to get to like 0.3 and eventually 3 dB per meter. And now we're talking because now you can make a modulator very long, low voltage, but lossless. So I think that was a breakthrough. And the other really important part is this etch happens on a time scale that is relevant for production. We're not talking about etching like at 1 angstrom per minute, right? So, which some of the material needs that, but this is not one of the cases.
Thank you, Mian. Alan, the same question to you. From your perspective, what are the limitations of silicon photonics?
Sure. So I think maybe an interesting thought exercise to do to answer that question is to think about what is needed or what happens to silicon photonics as you need to scale to higher aggregate bandwidths or more complex PICs. And to do that, generally speaking, your devices either have to get more complicated or you have to add more components. And the end result is there's higher loss. And so generally speaking, to scale to higher complexities or more rich functionalities, the limitation is, or maybe it's a feature, it's just that you have to add more components, and then with that comes additional loss. And then the main drawback is there's no way to re-amplify or regenerate your optical signal on silicon photonics without some additional material. So that is that's what I see as the main limitation. It's just scaling, complexity scaling, and not having a way to sustain that without amplification.
So that's where your technology comes in, because those quantum dot devices can be made on silicon and provide for amplification, relatively low noise amplification.
Yep, exactly. Okay. So yeah, we're looking at, there's a few things where the quantum dots come in. One is, they make really nice multi-wavelength lasers, and that enables the DWDM architecture that we're working on. The other is we're looking at integrating both that material with silicon photonics for both lasers and amplifiers. For datacom, amplification without adding too much noise is important, and it turns out that quantum dots are also good at making SOAs with low noise figures. So that's kind of where for us, where things kind of tie in.
Okay, perfect. So Chris, a question for you. You have a very different technology. It has a big ecosystem behind it, but what's the best way for new technology from outside of the mainstream to enter the market? How do you see that's happening?
Yes, excellent question. That always comes up when someone comes up with an interesting new concept that looks very promising, but how do you get it into the market? But if I may, I'll go back for a moment to where I think silicon photonics has delivered very well, and then where we still see the challenges, and that kind of led to what we're offering. The founding team of Abyssina actually has a long background in kind of classic networking optical communication. So I think on the long haul side, and a name that comes to mind often is Acacia, silicon photonics has definitely delivered. I mean, on the long haul side, the coherent transceivers with lots of elements, silicon photonics has really worked well. As you're getting closer in, I think today silicon photonics, I would say, coexists with the traditional EML, DML, or VCSEL-based approaches. And one of the challenges in silicon photonics that we see is it's single mode based, and single mode, especially massively parallel single mode architectures, they're just a pain in the backside to package. So which means packaging cost is a challenge. And as we're going closer in now with the communication, so now we're looking at chip to chip, which interconnect is rapidly becoming the bottleneck in a lot of these HPC architectures. I mean, there's a lot of talk about that because the electronics is mostly done electrically today, and I think the statistics are that over 80% of the energy inside of these architectures are actually used to just power the electrical wires, to overcome resistance and overcome capacitance. So the birth was, so if we want to go massive parallel, that's the other thing in the chip industry. Massive parallel is internally these ICs run with relatively slow but massively parallel buses. How could we extend this? Is there an optical technology that could do that? And that's where a micro LED display with 1 million pixels, which already exists. They haven't quite hit the mainstream yet, but they're basically in prototype phase. That's what these displays do. And then the next step was, okay, now we need to figure out how we can make this run faster, because the frame rate is not good enough. We've now demonstrated these technologies up to 10 gigabits per second for an individual link. And then you just go massively parallel, but you can do it in a fab-based process. So you now have a way to fabricate massively parallel links at very, very reasonable cost. And then, I mean, one idea was, well, just do it free space optics, but actually having it in a fiber-based and being able to route it specifically to where you need it to go, for processor to processor or processor to memory, is still a big advantage. That's what the market seems to be looking for. So leveraging that, and then the other interesting thing that we're finding, because we're addressing this this burning need, I've done a couple of startups, and usually you have to earn your right. You work with tier 2s and 3s, and then you have to work your way up until the tier 1s actually give you the time of day. And that's not the case here. We're getting pulled into the tier 1 companies, both on the IC side as well as the hyperscale operator side. On how can we get this the scale? What help do you need? How can we do this? So it's leveraging existing ecosystems, and yeah, it always takes adjustments, because otherwise you're just doing the same thing that already exists. That's not how it works. But this looks very promising.
Thank you, Chris. So I'm going to hand it back to Andy, and on your favorite issue of the power consumption of the industry. I know you have some announcements to make.
It's not an announcement. I wanted just to restate that for different applications, there's almost certainly going to be different technologies. So the problem inside the rack, a few meters, is inherently different than a kilometer in the data center or 100 kilometer, DCI. One thing, that going back now to the OCP angle here is, we want to basically establish an optical track where interesting new companies like the ones we have on the panel here can present what they're working on in an open way to the public, because the key attendants of that show are actually the largest hyperscaler companies that are spending a lot of money on optics and optical communication, right? So I think there's a good match between the audience we have at the show and people that are working on interesting optics. It hasn't been the focus in the past, but that's well worth it. But to make it a little more interesting, we decided to add a little competition here, and this is a competition for glory. There's no prize money, but it's a competition for the lowest power. In other words, people can, and there's two categories of optics. One is products that are shipping that have like a data sheet, and you can order it, and you can enter your data sheet value into the competition. And we'll establish some band. I mean, it's like you don't have to be at 15.1 watt, the next guy's at 15.2 and you lose. There's probably a 1 plus minus or whatever 1 watt band there. But we want to focus the industry on power, right? And people who fit the bill will get a little ceremony or whatever. We'll mention them. But the second category is for emerging optics that are not shipping today, like the ones we're talking about here. And it's understood that emerging optics are far lower power on the picojoule bit or any metric than the current technology. It's a given, right? You have it's a different material systems, different speeds, different assumptions. So we want to showcase both types of technologies, right? Both what's currently available and what may be coming a year later or 2 years later. And we do believe that focus on power, like here's what the rail is today, in an open discussion, right? Where yes, there's no NDAs here. Okay, so if people don't want to participate, they don't have to. But if they participate, whatever they say is sort of publicly known, is helpful for the industry to advance more quickly. And this is a useful role OCP can provide as a platform in the annual summit in particular. So anything else? We still have to figure out the exact rules for this, but most likely there's a deadline, which is the same deadline as putting in your papers. So you have to know what it is on that time, and then there will be some jury that will look at this and conclude. But we do want to give time to promising startups. I think that's the most important aspect of this. Because people know who are shipping volume optics, and they get the price bucket there. But the interesting part to me is what's next. And both discussions I think have a lot of merit.
Well, this is first letting people know, and we'll make an announcement, a formal announcement on that as we get closer to summit. How the structure is and what are the criteria.
And the summit this year is in October, right?
It's going to be in October, yes. Mid to late October.
18 to 20th.
18 to 20th. So the deadline is sometimes in
We all got the
September,
email.
okay?
Yes.
So the deadline here is sometimes in September. So what is it, like 30 days before something?
I'm not exactly sure.
Yeah. We'll announce it all.
Right.
So whatever you want to put into the little competition, be ready in roughly 6 months from now.
Thank you,
But
Andy.
we also wanted to give people 6 months notice that this is going to happen, right?
And
so
to
they
think,
can get ready
to think ahead.
and put in their 5 nanometer DSP and so on. Right.
So, yes, I'm just about to open it up for questions to the panel, and Also let you know that this was not a free lunch. So what OCP is asking you for is provide you feedback on what's the best way to structure the discussion, open discussion, that would help emerging technologies, new startups to kind of get into the mainstream of the industry.
And just to be clear, that the OCP is not an MSA that sets very specific standards for 100 gig lambda. I mean, there was some MSAs that did a lot of useful work for the industry, much more effectively than the IEEE, who for whatever reason seems to take a long time to do anything. So the MSA problem is more or less solved. However, the focus on what technologies make the most sense, I think need more interaction basically, and an open way to interact is just the best way to do it. And again, OFC here is a useful venue, but we have an off-cycle 6 months later, another event that I think can be just as useful.
Stefan.
Stefan.
Oh, my question was just a detailed question about your competition, and that is, you need to talk about what kind of reach you're talking about, right?
Yes, there will be different categories, for sure. Yeah. There's like 400 gig DR4, FR4, CR. I mean, it's by category.
But I'm thinking about the emerging ones, right, which I agree with you is really...
Well, the emerging ones, it's more wide open, right? And
Yeah.
I think those are more interesting in not simply picojoule per bit thing, but they have different use cases.
Yeah,
I mean, the emerging field is wide open. It's the shipping part where there's clear specs. The emerging ones, I don't think there's a spec yet, right, on your technology? Okay, the spec is true.
There's a draft spec.
But it's, it's a chip-to-chip thing. It has even longer lead time, but it's important with the discussions sooner than later.
Right, because, I mean, I'm with a big company, right? We require maybe little companies, and I agree, the little companies is where a lot of the innovation happens, right? The emerging companies, and they either grow into a big company or they get, make an exit into a big company. This is kind of the continuing cycle of evolution. So I think this kind of a competition that lets everybody showcase.
Exactly, it's a showcase. That's what it is.
And it promulgates this kind of exchange of what's possible. Because without that, we are all hiding behind our hands,
Exactly.
right? Nobody's really quite opening those up.
Right.
Well, thank you for the feedback.
Any other questions, comments? It's an open discussion now. Ashok.
I think it's a fantastic idea. It's great. It's a breakthrough for, I think, the innovation, I think. The question, though, with every competition, there has to be some validation.
Thank you for bringing this up. So we're not going to measure any power levels for anybody, but the rules would be, for the shipping products, there has to be a data sheet. You have to commit to that number in your data sheet. That's easy. For the emerging ones, we like people to have measured numbers out of their lab. We'll take your lab data, but it should be more than PowerPoint projection, if you know what I mean. So we like to see something that was actually measured, not projected.
So there will be unannounced spot inspections.
Yes, yes.
You do the presentation. Like, if you get nominated, you get some time to speak there, right? And you can present it, but you don't want to say something different a year later.
No, I was going to flip the question. I thought, in companies,
That's a good question.
there could be, for example, an OFC technical session.
Yeah, no, exactly. There will be a technical track, but in the past we never focused on optics because the OEF did that or some MSA. But the time is getting shorter. We got to get there faster, and the investments are getting bigger, and we can't. There's no point to invest in 5 things. You only need 3 things or 2 things. So there's we need to get people more interacting. I think that was the basic feeling. And the audience is there. The key players are there, right? And we want to get the key optics innovator in front of them and so on.
So, go ahead.
We can do it in real operating conditions. Yeah. I think it's a good idea. I think one of the things we see as a test making vendor that really hurts the ecosystem industry is the form factors. And I think one of the big success stories that's what's made Ethernet successful is the port rate. The end user can use it to move megabits to gigabits, 5 centimeters, 50 kilometers, and it just works. And it's very reliable. I mean, it's harder to get plug out of a socket in every country on this planet than it actually is to use Ethernet. Every country has its own imaginable way of extracting power, but everyone uses an RJ, and it works. That's the great thing about it. To the end user, it scales really well. And one of the things that really hurts us from a T&M point of view is every guy has his own imaginative form factor. But now I think that I will congratulate Andy here that this OSF PXD story is really fit so many problems. At the moment, we have to bring out 4 different things because each guy wants to have his own imaginative way of plugging something in.
No, thank you for bringing up OSFP, and one way we improved it actually is we put the Cisco guy in charge of running the meetings. No, but more seriously, it shows case one problem, which is it's actually under NDA. Okay, you have to be a member to attend a meeting, because if anybody invents anything there that becomes a patent, we didn't want them to charge a royalty on the rest of the industry, right? So under the rules of the MSA, you have to do RMD, what it's called licensing, and that's fine. But it's not open, okay? Whereas at OCP, it is open. So we may have a special presentation on what's the latest is on OCP XE, but that's an open presentation rather than the one that is behind the paywall.
People need to get involved in this because nobody's out and contributing.
Yeah, I mean, there's a lot of been useful technical work done, particularly on thermal simulations and everything from the airflow to the heat sink height and how we get to 40 watts. I mean, it's actually amazing how many contributions there were in the last 2 months. I'm sorry that most of you are not members, cannot see this, but there's like, yeah, if you're not members yet, you're welcome to join. It costs nothing to join actually, but you're signing this thing that you're not suing anybody if you contribute something that becomes valuable. But again, at OCP, it's all open, right? There's no NDAs. And whatever people say, if they don't want to talk about it, they don't have to show up. But if they want to talk about it, it's an open conversation. And we do believe that's an important difference. And again, I'll encourage some of the other people to show up too, right? But
So,
That's a really important point, because in my travels the last few months, and the different people I've been talking to, certain analysts, everyone realized at the end of the day, people need to build a product and make money. And so, how does it work, right, from those of you that are members and living in the OCP world, so you have these open discussions, and then eventually you introduce your product, somehow you have something that you own, that you can make money from. So communism only goes so far. I mean,
well, actually, I don't think that's actually the problem. I mean, making lasers, making self-photonic chips is really hard. That's not getting open sourced here. What we're talking about is the interfaces. We talk about form factor, optical specs, things like that. And because of the lead times involved and the massive investments that need to be made to implement it, the important thing is to agree on specs sooner than later. Because you can't really commit to doing this thing until you know there's a volume market for it. It's a chicken and egg problem. So the discussion is always around the interfaces, what the magic processes you guys use to make this work. I mean, that's behind the kimono. But the interface is the essential part, right? This is where suppliers plug into, and we want many suppliers in this ecosystem in case there's not a supply chain hiccup, right?
That's an important point. Define interfaces, then companies can innovate with their instantiation. They can actually choose they have a better flavor laser or a better flavor modulator than the other guy. But because those interfaces are rigorously defined and understood at scale, that works really well. So it drives innovation. It doesn't hamper innovation necessarily.
Yeah. Now, for example, even at the chiplet level, right, where Intel and others announced this chiplet alliance now, you can add optical chiplets into that interface, right? And this may enable some of these technologies to become very successful. But without that as an open standard, it's really hard that they would even know what it is, right? Because it was an Intel secret before. So it's an example where even the largest semiconductor companies realize they have to create ecosystems around interfaces to enable a future ecosystem that will inherently have multiple participants.
I've got a question for the panel. Silicon is very amazing technology, offers a great deal. There's so much of a base out there existing, like infrastructure, based on other technologies, more mature things. And quite often there's a tension I sense where people know silicon photonics could do so much more if they just change these specs a little bit, be more suitable to the modulators one might choose to use, that leverage silicon photonics advantages. But we seem to be bound by our history. We have to break, or do we think we have to break this, or can we just, is it going to be a gradual ramp? Yeah, that's my question.
Yeah, I mean, there are some conflicts, right? I mean, at the IEEE level, certainly, any IEEE spec was always inclusive of any implementation technology. You had to be able to build it with DML, EML, and photonics. But in reality, you could have made better choices for silicon photonics, but it would have been harder to implement the other way. Maybe going forward, when we talk about much higher capacities, much more channels, EMLs don't work as well when you go to 16 or more channels, then the silicon photonics spec becomes the optimization point, right? And that would have perhaps lowered the power even today, but it's not how the spec was written.
How do we get there?
Well, it's too hard to change the past, but there's new specs every 2 years, right? So that's where the MSAs that they actually out in the end have to agree as a vendor consortium what they're going to build, because it has to be interoperable. But there may be a time where silicon photonics becomes the dominant implementation technology, and then that's the right spec to write.
But we also have seen that large customers are willing to modify the specs, kind of deviate from the standards to make it easier for suppliers and to get the best of optics. Say it again? Standards are too slow.
Define what we see as the use case, and that's kind of driven by the industry. But I think, to Andy's point, I think to be fair to sort of technology development, having a baseline spec and sort of defining what we actually need, I think that's a good place.
It's a good starting point. Right. Right.
I think one of the problems is all the hyperscalers. Like if you ask me versus Meta, I can't speak for them, but we all ask for different things. So that's part of the problem, but at least, I mean, that you want to define the specs well, but loosen up that, there's some wiggle room or something that would be kind of.
But I've seen more interactions between Google and Meta over the last 2 years, and I've seen both of you being active at OCP. Why don't you have more discussions? Deviate this from the specs in the same direction.
I've been at Google for 11 years. The first 4 or 5 years, there was really no problem to really talk. I think we were driving most of it. I mean, it's our team.
I agree. Yes.
I think more recently, we're seeing more benefit in learning standards, et cetera. So just because the problem's getting harder,
Right.
having some consensus is good. Also to the vendors, to be fair to the vendors, supporting 10 different flavors is not good for anybody. It's not good
Correct.
for them, and it's also not good for us.
Correct.
Because that delays the product. They can't turn the crank as fast. So I think some consensus is definitely good. But I think the main thing is it should be driven by data and good analysis. And so because that's how we made our decisions. So
Right.
again, defining a good set of requirements with some tools, I think that's important. But I like the analysis. I'm not going to go into it.
Any comments from Meta?
Yeah, so actually within OCP, at least we can think of 2 projects right now where both Google and Meta are involved. These are not related to optics, of course. But philosophically speaking, the approach is exactly what is being discussed here. So the idea is we need to decide that this approach makes sense for attacking a lot of complex problems. Optics is one of them. And then another area where modular hardware system design is being pursued in open compute, where there is a base spec which everybody is agreeing on, which is fairly loose. Using base spec, companies can evolve their design spec, which has variations, and then using design specs, vendors can come up with product specs. And I think that philosophically can be an approach which can be used in any situation, including this. So having a base spec which broad community agree on, and then just like evolution, different species evolve over a period of time, and then if there is a real market product fit, then differentiation will happen automatically. But you don't want to have gratuitous differentiation. And I think OCP's fundamental philosophy from day one was to avoid gratuitous differentiation. Now, I also see a lot of times that, I mean, this might sound odd, but you have a lot of smart people and a lot of smart companies, and they want to feel that they have provided value in the organization, and they think of, gratuitous differentiation. This is the nature, human behavior, right?
Right.
If you hire very smart people in very smart companies, they are going to say, I'm not going to agree with the common because I need to do something unique. And I don't know how to solve that problem, but I see this as
But that's where the data and the simulation,
yeah.
you're basing on after.
Right, but a lot of times, data and simulation also is something which can be interpreted in different ways, right? I think there's some amount of give and take which people have to kind of relax and then say, hey, let's agree on this broad spec, and then everybody will differentiate.
So if we look at the history of silicon photonics and how it penetrated the market, it was really hard for new technology to meet standards. So the first products that we've seen were active optical cables, where vendors could use any optical technology within the cable because it was all inside the cable, so they didn't have to conform to anything. So meeting the standards that were built around indium phosphide or gallium arsenide was very difficult for silicon photonics to begin with. And I think it will be a barrier for other new technologies as well. So in a way, standards is a way for established companies to protect their turf. They need it, they serve a function, but it's a limitation of innovation to some degree. So new technologies may need to search for alternative solutions, whether it's co-packaged optics or some different. Active optical cables is a proven way of getting to the market because all the optics is inside.
Actually, case in point, that's one of our first products. So to the outside, you look like a standard, and then if you deliver on the overall specs, people kind of leave you alone on the inside. But of course, you have to operate within your limitations. But to just comment a little more, I also see it as it evolves over time. Initially, the specs should be fairly open, so you give a chance to different technologies, may the best suited ones prevail. But then as you go along, at some point it becomes more of a multi-sourcing ecosystem, and at that point you do have to narrow it down so that you have a healthy.
OCP is pursuing the layered approach. So you have a base layer, and then you have narrowing, which happens as you go up towards the product side.
Yeah, I think that does make sense.
So base spec may not even specify physical dimensions for it.
And not to revisit ancient history, but one thing we just talked about, which is the difficulty in silicon photonics, in my mind, really related to a failure at the IEEE 803, but I didn't want to standardize Honecker Q CLMM4. I mean, I still cannot believe how the organization in charge of writing standards didn't want to write the standard that the largest customers were asking for. And they spent like 2 years and never got to the 75% majority vote because the LR4 vendors didn't want to build it, right? You remember this? And then what happened was Intel proposed the spec at the time, right, which was perfectly fine, but the guys at Broadcom decided they wanted to write a little different spec, and they made it a club, and that delayed it again, right? So it was an unhealthy way to develop a specification. It could have been done much less painfully 2 years earlier, but for whatever reason, let's not repeat that experience. That's what I'm saying here. And then we wouldn't do that at OCP either, right? But we want to have people talking that says, that's what we want to do, that makes sense, let's get it done, rather than we're waiting for some act of God to approve something.
Mian, how are you entering the market with your new technology?
Sorry?
How are you entering the market with your new technology?
I think related to this standard, I think I can maybe provide a little bit different view from the startup angle. So in the very beginning, I think, I really like what Meta brought up about this view about, like every startup wants to do a little bit different. Like when this technology was just born, we think, oh, this is the greatest technology in the world. Like, industry are slow. We're the innovators. We want to do something different. And wouldn't be nice if we have standard that just designed for this material. But actually, I think that's the thing. You want to be very careful about what you wish for. And now, we're a few years into it. I see a lot of value in standardization. I started to embrace them. Because what's the biggest problem? Okay, if you don't have a standard, or if you're doing your own standard as a startup, if the standard is too loose, try to convince the supplier, right? You're asking the supplier, hey, can you make this specifically designed component for my chip? Supplier asks, what's the volume?
Right.
Are you willing to pay $1 million NRE? Right? If you said there's no volume, there's no standard, I'm doing this just for my chip. The supplier says, okay, there's nothing, nowhere else we could sell.
Right.
But now I tell the supplier, hey, can you make this for me? And if that's a standard, supplier says, yeah, that's easy. I can just give you free samples.
Right.
And so that's the part. I think that's why when we look at new technologies or how we bring our technology to market, the question asking for, I think startups should also try to open mind a little bit in a sense that the standards, they are not all limiting. They are sometimes it's good because now the component becomes so complex, no one can solve all of the problem by their own. Essentially, it's startup. They don't have the experience. They don't have the money. You have to leverage the ecosystem.
Right.
And to leverage the ecosystem, you have to work with standard.
Right.
So standard is cost effective. So
Alan,
that's why it's important.
what was your experience in bringing products to the market?
Well, I've not shipped a product yet, so no answer there. But in terms of my answer to the question that you asked me, and it's similar strategy as Chris mentioned at Abyssina. I think we're thinking that initially the first product will have to be proprietary or bookended at least. But that's not to say that there's not some level of standard. To Ryohei's point, I think there's a baseline level of standard that you can specify, and for the products that we're pursuing, which is optical connectivity, there's the electrical interfaces, right? And that's what OCP is doing. And activities like UCIU from Intel, knowing what our PIC is going to be talking to, that's sort of the very first level of the interface. And so, like Chris said, that looks like an active optical cable. So we're developing the platform to sort of ship in that form initially, but keeping an open mind about where standards might land. So we're participating in the CWWDM MSA. It's looking at standardizing high wavelength account solutions beyond Ethernet, right? And so it's sort of ongoing, and who knows when or how it might evolve. But it sort of paints a general direction for things to trend. And so we're developing the platform to sort of roughly align with those, that general direction, so that when standards do develop, we won't be straying too far from it, and we'll be likely compliant with it.
Right. So standardization is notoriously slow. And I'm wondering if, OCP...
It depends on the standards group.
Okay. IEEE standardization is
Yeah,
notoriously
that's the
slow.
worst case, I would say.
And I'm thinking that, one of the roles that OCP could play is to help at least guide their thinking, because by the time they come up with the standards, it's 3 years later. So if we have a discussion on emerging technologies and, put them in perspective, at least, let the standard bodies know what's coming, what's potentially coming. So the future standards can be a bit more accepting of potentially new technologies. I'm not sure if it makes sense. And again, feel free to comment on your ideas how OCP could help with getting emerging technologies.
I'm a huge fan of the glacial timescale IEEE, but ultimately it's contribution-led. And I attend them, so I have a vested interest. It can go faster if people contribute. There is a certain core of people there who are very thorough and would like to do things quite methodically in great detail. But ultimately, if there's enough consensus, enough drive from contributions, it can move quicker. And you can actually see across different teams, there's some standards where perhaps I won't say young blood, that's probably not the correct, but there's perhaps a different culture there. It can actually move quite rapidly. With some of the newer technologies, people like to see contributions on what technologies can do what, and parts of these channels, modeling, market viability. But all of that is contribution-led. So I think one of the things is don't sit on the outside and throw stones. You can make it go faster.
Another option would be to invite the core of the IEEE standard people to attend OCP panel, to have them, to have those interactions, not only with new companies, but also with representatives of hyperscalers. So in a different environment, if it's an IEEE meeting, there are a lot of tensions. It's an off kind of record discussion. Things could evolve differently.
Yeah, if you look at the 100 gig Lambda MSA, between the time they started until they had the 100 gig MSA spec written, it was like 3 months. They had meetings every 2 weeks by telephone. The right people attended. The people want to make it happen attended, and there was no slowing down because we're the previous standard or whatever. That's the way to get there faster. And the frustration I have with that really is between the voting rules, the speed of the meetings, if you have a constituency that is not aligned on the outcome, people can drag their feet forever, literally. So to me, OCP is more like the IETF. People can propose a new RFC, a new idea. It's very inclusive. If it doesn't go anywhere, it doesn't go anywhere. But they came in open discussion without, it doesn't conform to this, chosen, whatever it's called, par election. And if you're not one of the 5 things, don't show up here, right? So we need a more open discussion than ever happened at IEEE. And that's true in particular for the new immersion technology.
Manish, any comments from Broadcom? I know you're a big fan of standards, MSAs.
I'm glad you're still going there.
They're necessary. I think there has been some progress in speeding up activity in recent years. But I think the investment dollars are just getting so high on a lot of these activities. And you have to start before any standard is finalized. You're going to have conflict, you're going to have fracture areas, and I think in some cases we have to be okay with that. We have to let some variation emerge. We're talking about a 30, 40-year journey in which optics is going to progressively take more and more of the connectivity content in TAM. This is the very start of something, that's going to last for a very long time.
Did you say 30, 40-year journey?
100 years. But I mean, we're all seeing all the same limits on copper and new architectures that are going to drive significant increase in optical content.
Paul, any comments from the investor's perspective? I loved your comment on the executive forum of how to restructure the industry. Let service providers make money from bandwidth.
Well, if you think about, even God forbid we treat telco companies as utilities, but the thought arises to the point Vlad just made. Last time I checked, and we all use electronic appliances, TVs, whatever it may be, utility companies participate in economics. They get paid, for usage. And telcos need to be healthy. They need to participate in the economics of the applications that we all use and love. I think that's a threshold issue, but that's a separate. The question you asked, as I sit here and listen to all of you, and by the way, one is the cheap seats, as a member of the investment community. It's just amazing that any of this stuff works. One, and two, I applaud all of you for the unbelievable technology value that we all deliver. That's just an entire appreciate it. You don't need to hear that from me. But the thought arises, if I think back to the 90s in the last decade when Andy was slaving away at Cisco, you had if I remember, I may be way off base here, but Cisco set de facto standards. There was open standards, and then there was the Cisco de facto standards. And being the dominant player, similar to the way Broadcom is today, apologize for coming some more words, strong player, or Google and Facebook. I'll start with Google and Facebook. At Google and Facebook size, you don't need open standards. You guys can dictate, and I'm not saying you don't want open standards, but you can dictate what the entire ecosystem does. From Arista down to Broadcom down to the smallest components of parts. They have the volume to do that. And the one thing that I think I understand the tension. I'm not smart enough to understand how to reconcile it. But by definition, open standards are somewhat antithetical to profitability. Not to a Broadcom, not to an Arista, but to startup companies where, it's unbelievable the amount of investment this industry requires relative to the relative sparse returns. At an industry level, as I'm sitting here and listening to all of you, I'm thinking to myself, how many companies are coming on the ones that have been successful relative to the ones that have failed. Unbelievable technological effort that you all know far better than myself. Time, effort, complexity, and the money that's required in the payoff. Right? In the world of optical components, most optical component suppliers, if they're lucky, they get to 35 to maybe 40% gross margin. And the ones that do are very, very few, and they're the largest. I can cite all sorts of transactions with Thomas and Clara, and just a slew of them, including recent ones, where the companies in question, pretty decent-sized public companies, they weren't big enough to be standalone companies from an economic perspective, from an investment perspective. Photonics, wonderful technology. Right? Now running with typical lasers, they're more and more valuable as line rates go up. 11 years as a public company, they made money. They were profitable. 2 of those 11 years. In those 2 years, the profitability was de minimis. And that's no phenomenal technology as far as we have. So I listen and I think to myself, how do you reconcile
But I think it's clear that at the level of interfaces, whether they're electrical, optical, form factor, whatever, it only works in volume, right? There's no point to invent another version of the Swiss cheese if you have one that works already.
My apologies, because when I was listening, I was thinking, what you've described in the interface reminds me of OpenAI and software.
Then we're talking where, like the latest Intel,
The UCIe?
Exactly. I mean, to tape out chips that have a certain bonding pitch, they have to match the other chip. You're not going to do it twice, right? There has to be an agreement on at that level. And I mean, Google can pay somebody to do it in a different way, but what's the point? You might as well copy that standard and put it down, right?
Yeah, I apologize. On your specific initiatives, I think that's brilliant. I think it should have been done years ago.
Yeah, and I think the industry recognized that, right? There was a lot of participant in that particular announcement that all believed they're better off together having this common interface.
I think the challenge is that for you described it, the ecosystem, the modular component, the sharecroppers. Even if you win, you're still beholden to your biggest customer who does everything because it's an open ecosystem. They can go and buy there, not go somewhere else. So you effectively, even success is a sharecropper. That's the best you can hope for.
Or to put it another way, from a game theory point of view, if you have a lot of suppliers commoditized across the standard, then the customer can play them off each other.
Yeah.
Yeah.
The thing is, it's more supplemental. This is why we use the share model.
Yeah.
The optical companies use a tremendous engineering companies. It's not just photonics. It's signal-to-noise electronics. It's power, thermal engineering, integration. They are masters of 4 or 5 engineering disciplines. And even if they can pull it off, and that's a big ask, they're in the scale. So they're taking all the risk. They're taking all the risk of the technology, developing the fabs, the lasers, really innovative, very smart guys in multidisciplines, and the best they can have. Like you said, if you go optical cash, is that how you want to invest it?
Well, there's a way out of that dilemma, and that's something that is a disadvantage of being a startup. I've been many more startups than I have been since I went to the dominant player, and that's operations, that's manufacturing. Now, a lot of people outsource their manufacturing, right? But if you've got, because as you said, in a perfect world, let's go back to 10G when we had SR and LR. So what differentiated people there? How did Avago and Finisar, how did they become dominant players manufacturing? That's the other element, and that's as a startup the most difficult thing. So you try an outsourcing model, you try to get there in other ways, right? That's the other thing.
Do you mean manufacturing in terms of you can respond to demand profiles, or do you mean that you can just end up selling a module at a cheaper?
Yield at cost.
Yeah. Well, I was thinking yielded cost, but also you control your own destiny, right? So yes, you can ramp, you can make choices, you can choose who your customers are. If you manufacturing is the powerhouse that you must ultimately have, either by being outsourced and going to a CM and having enough control over your CM that you can do those things, but that's more challenging. Of course, it's a massive investment to have it. Right?
Yeah, that's.
Once you have it, you have an unfair advantage.
But that's the other component. I mean, there's many startups that try to kind of control their own manufacturing destiny and just went broke doing it. So you need to have that scale.
It's really hard. That's the thing that doesn't work.
But that's why Fabrinet was very successful, because they offered this manufacturing platform to many small companies as well. So.
Otherwise you had, back in the day, you had a lot of
So we should probably get involved with companies like Fabrinet that help new technologies to get the manufacturing done. So maybe engage them into the OCP community and make sure they get to see new technologies that's coming up. And,
So bringing it back to the very beginning of the conversation, which is what happens after silicon photonics. My opinion is that it's not really what happens after silicon photonics, it's what happens next in silicon photonics in order to get massive adoption, and then that goes back to interface, both electrically and optically. And then you say, okay, well, how do I bring that interface in sooner? And then move it through a consortium or OCP or whatever, right? But you've got to get that first initial agreement between the various interfaces of silicon photonics and the various end customers that need those solutions, right? And that's where I think we're kind of stuck right now, is that for the device and component and optical suppliers like us, we don't know what to do because we have to be, basically, we can't tell you, you know, this is how you should really make this, right? We can't tell you that. So what helps is if those players come together and say, this is the interface that we need.
Sorry, when you say interface, is it what type of interface
Well, I'll
is
give
it?
you an example. It's basically the optical interface for any kind of silicon photonics. Everybody's silicon photonics chip is different, right?
So you mean
how-
fiber coupling? You mean fiber coupling?
Yeah, how we
Okay.
fiber couple it is
Okay.
an example, right? But I think that also probably applies to electrical as well.
Yes.
I don't know personally, but on the optics side, that's what happens is some of the light comes out vertical, some of the light comes out horizontal, some of the light, you know, and how to actually finally interface that within the rack and outside of the rack, it's $1 million question.
So if we pull on that thread just for a little bit on the electrical interface, I mean, the OCP ODSA has actually driven quite a bit of discussion on, let's say, the kind of the parallel interfaces that are really at the chip-to-chip level that silicon photonics and co-packaging is now getting into. But somehow, at least up to now, and now we have let's call it the Intel initiative around UIEC, it hasn't quite worked yet. I mean, where do we need to kind of take it a step further?
So the problem which Chris is mentioning, OCP routinely solve that problem, where participants come together before anything is done, contributed into OCP, exactly what you're saying. OCP actually has a structure, they have done it more times than other organizations. So there's still ways to improve things because for optics, maybe there are certain things which OCP doesn't do. But there are ways and processes already within Open Complete where companies can come together behind the door, we form a standard, and then we release the first version of spec to the community, and then the community goes and iterates on it. So it can be done, and it has been done within OCP. Now, of course, you know, OCP doesn't have optical community. So they traditionally, you know, the inception of OCP was more on the data center side and servers and systems, and now we are talking components, and ODS is the first time we are tackling the components. So I think maybe that's one area to go and see, hey, are there tools available where this problem is 80% solved? Maybe not 100%. And then because of my unique optical knowledge, I will fill the gap of 20%. OCP will provide all the structure, legal and otherwise. And then standards come out very quickly.
Yeah.
But this is a problem for many, many ways in which when companies are trying to collaborate.
Go ahead.
I think if you, like, to the detail that you want in terms of, you don't want a marketing part. You just want sort of, hey, this is the only interface. But if you go to that detail, like, what's the optical coupling scheme, you won't get consent.
No, exactly.
It's not gonna happen. Right.
Yeah.
That's the problem. Right? So
That's the problem.
So this is where I draw that line.
With having Greg like 6 layers down, statistically, 3 years ahead, if you're going to do 224 gig PAM4 or PCSK, that would be a start.
think that's just some level, but in terms of new initiatives like AI clusters, right? Everybody's trying to build a bigger AI cluster, and the amount of bandwidth you need just between the chips on the same board and the same rack is just off the charts. It just didn't exist before. So there is a new demand that is novel, let's just say, in terms of the nature of the distances and the bandwidth required, where chiplets or co-packaging may be the perfect solution. Doesn't go much out of the box, but the problem isn't solved actually for the next generation of AI chips in an important way, because they would run better if they had a lot more bandwidth.
So maybe that will be the area where a conversation could help to set up, direction.
I would say for the AI stuff, I mean, if you look at our TPU, that's like a custom ASIC for us.
I know.
Something that makes things worse when we're bifurcating. That's it.
But as far as optical,
Just that, yeah.
but as far as optical connectivity to those chips, that just the optical connectivity itself to that chips, would that be a better direction to start?
I'm running a panel today, talking to a better person, but I think their I/O requirements, their architecture is very different. I think our TPU and the way we architect our system is
So there's difference in architecture sim at the AI level, yeah.
So
and we look at things, we're solving different problems.
Yeah.
okay, so it's fundamental. It's not just.
Optimizing as, basically the effectiveness, per click, right? So
These guys need that Microsoft needs a little power. Everybody's got, you guys at least.
Fair.
But as AI develops, right. But
that's our differentiator.
if we think ahead, if AI develops to applications that are not going to be just important for Google on search or Facebook for targeted advertisement, if we see like consumer applications of AI and let's take self-driving, for example, or something like that, or I'm not sure, face recognition. If there are going to be more standard applications of AI, do you think we'll see more convergence in the hardware supporting it?
That drive optics?
Say it again?
That drive optics?
Yes, eventually.
I mean, I think those are on kind of peripheral devices, like edge search. We have like an AI chip in our, like, this is not the latest graceful, but we have it. But maybe that's, but I don't have like optical interconnect. I mean, this is not a big system, right? So the problem you're solving isn't really relevant to optics.
No. I'm still talking about AI clusters, but AI clusters developed to support new applications of AI, not necessarily what you have now.
And everybody's doing the same thing in certain instances, so maybe there's some purpose.
That's what I'm hoping for.
Well, actually, can I ask Ryohei, do you see a scenario where maybe the TPUs adopt some of these standardized chiplet interfaces, like UCIe or AIB, something else? Because then that kind of opens some playing field for optics.
Yeah, I mean, TPU, sure. I haven't thought of the chiplet thing. Yes, we're a part of it. So, how does that affect optics?
Well, if the electrical interface is known, then
I mean, it's open, so sure. I mean, but I think optical chiplets, again, for us, there's CPO discussion. We don't really see any need there at this point. So, but others might differ. Like, my NVIDIA speaker today said, yeah, I/O is a huge problem for us. So I need CPO to open up sort of basically the beachfront and stuff. And I was talking to an HPC person and said, yeah, same for me, but we don't see that. So I think it could help, right? Because that interface is there, but it depends on who your customer is.
But that is interesting. I mean, that statement is interesting because several of these parallel chiplet interfaces are very similar, but they're still just different enough that, let's say for the optical community, we can't build to one. We sort of have to look at the different electrical interfaces.
No, yeah, I mean, having like I think for you guys, having a target, like at least somewhat defined, that helps you guys. And
Yes.
if you want to deviate off that and say, I'm just going to ask everybody to adjust to me or, try to get close to the standard, that's up to you. But having like a requirement is always good. Like when you build a system, you have to start with a PRD, right? It's a product requirement of having something like that for you guys is always good. And if you don't want to
Go ahead.
What is common as well the picojoules per bit competition that you talked about? I think that's a more relevant number for the data center industry because they seem to care more about the power consumption. The AI industry has kind of said, we'll just go to this little, we don't care that much about it because it's not as that scale as the data center power consumption. But what is common between the two is the beachfront width density. That is a common problem across all high-speed communication, whether it's data center, AI, high-performance computing. Picojoules per bit would be a great competition, but looking at beachfront density, comparing that kind of technology, and that will be common whether it's optics, whether it's copper, whatever. And it will go over many different industries because AI doesn't care that much about power.
I don't think that's true at all. I don't think that's true at all. Well, maybe it's a different power number. I think you care a lot about socket power because every single watt you put into I/O is a watt you're not spending on what the customer is paying for, which is compute. So I think that there's
No, the sensitivity is different. That's why
right. So I think there is care. Or if you look at the big HPC, so architect AI or big HPC, there's a number of dollars, there's a number of watts. How do you get the most compute out of those two? So I think it is important. And they're not mutually exclusive. You don't have to give up power to optimize density in the content levels. So I think you can absolutely go after those.
I think you're making a different point though. I don't think you're disagreeing with the fact that power is important.
Right.
I think he's trying to highlight that there's another metric that could lead to different winners.
Right.
Or the different technologies that could highlight their particular strengths.
I mean, that would be the chip level track, basically.
Right.
Yeah.
So you can have another track.
Yeah.
I think that's what you're saying.
Yes, exactly. Sorry, you said it better than I did.
All right, we're making progress.
Up until 25 in delay, everything's spec-free. The optics are very good. We have a channel where we can send photons 10 kilometers without needing it. It's error-free. Then with PAM4, suddenly we start having to bolt effect lock on. And of course, could you get photonics to work that well? And the question, I guess, for the panel is there a path for us to stop throwing transistors at it in the form of FEC and actually get the optical engineering good enough that we don't need a FEC anymore for the majority of reaches? Is that a path we should pursue? Because it seems now that we've baked in, we're always going to have FECs again and everything going forward. But is that the right approach?
Yeah, I mean, one of the easiest ways to save power is to get rid of the DSP and do direct drive, right? Now it's working at 10 to the minus 9 right now, but it would be better if it was 10 to the minus 10, right? So I think that's going to happen shortly. It was just an issue of the Reddit SerDes spec, which is not the IEEE channel, but an enhanced version, right?
Go ahead, you had a comment.
I love that. Transistors on it, and Moore's law works well, and power's not that.
Okay.
So, and especially for the like for long haul, it's not latency sensitive. You're going to like 1,000 kilometers per terabyte.
Well, I'm just going to add to
It
exactly.
really adds on. It really depends on the application.
Exactly.
So you're saying
That's fine.
it's actually better to throw transistors at the problem than engineer the photonics to
That's
do it.
the way it's been for like
Yeah, yeah.
optics forever. Right? I mean,
Yeah, I agree with that.
transistors work. Digital works really well. So that's if you can throw the problem at that, then that works fine. I mean, I think there's a trade-off in terms of obviously throwing too many. You want to be efficient about it, but at the same time, Moore's law still works.
Sure, but again, depending on the application, if you're going short reach, now you got your parallel interfaces, you can avoid any SerDes, then you can basically avoid your FEC, and if you can map that optically efficiently, I mean that's kind of one of the big drives for what we're proposing.
Like from memory interface, they check everything.
Yeah.
So they don't want to serialize, they don't want to back in on the stuff. And that's why it's like a very low speed, highly parallel loss.
So I'm looking at the clock. Ashok, sorry.
When
Sorry.
I first
Sorry.
thought about pulling this discussion together, I was worried that we would not fill the time. Now I feel like I'm cutting
I
it short.
feel like you need to extend the room.
So it's not we book for the room. Maybe we can continue the discussion virtually over the time board. So let's thank the panel for all their